Right. You said you. Good morning, all the students. Yeah, yesterday we already completed about the scalars and as well as the vectors. Here, the scalars nothing but what? Which are contain only the magnitude, but not are required to specify the direction. It is called a what? It is called a scalar. The vector is nothing but which contain a both. Yes, a direction and as well as the magnitude. It is called a yes. It is called a what? It is called a vector. Okay, now yes. How to represent the vector? You know very well how to represent the vector. We draw one arrow mark like this on a physical whatever a physical quantity is there, that is designated by like this. Means what? It is one of the arrow, and this arrow contain a what? One arrow mark. This is the tail and this is the head. We are consider this whatever the distance is there from the tail to the head, it is become magnitude, and this is gives the direction for us. Yes, this is only the representation of vector. Suppose AB is one of the vector, we represent like this, A to B. Okay, clear or not all this? And suppose force is one of the vector, we represent like this. Acceleration is a vector, we represent like this. Mass is not a vector, it is a scalar, we are taken only like this. Got it? This is only about our vectors and as well as the yes scalars. Yesterday what we have discussed. Now we are going to discuss about the difference between the vectors and as well as the scalars. Yeah. Now, once go with that, whatever the difference is there. Here, the scalar is nothing but they can be complete represented by their magnitude only. Okay, clear or not? They are denoted by ordinary letters. They may added, subtracted, multiple, divide with the simple rules of algebra. Yes, these are only the things here we consider. So suppose you take a scalar, yes, and as well as the whatever the vectors are there. Okay, now what is the differences are there between these two things? The first point, what the definition you have to write. Okay, it is enough. There is a what is enough. There is only just magnitude is enough. Okay, what is enough here? Magnitude is only enough here. Okay, now here not the magnitude. Yes, we required what both magnitude and as well as the direction. Both are compulsory. We required here. Okay, clear or not all the students? So both the things are required. Magnitude is required and as well as magnitude any vector it is there. Simply we use a letter. Already we are discussed now. Okay, now no need to represent any other thing. But the same thing, the AB is only we want to represent as a vector. We should compulsory mention like this. Got it or not? This is the one more difference here. Got it or not? We have to write arrow mark over the letter of the physical quantity. Okay, now already we are discussed. Velocity is the vector, acceleration is the vector. Like this here, we compulsory represent a vector above that here. It is only called as a vector. Arrow mark we have to should represent here. Next, come to the third point. What is the third point here? We are there. Yeah. Yes. It is already we are discussed. The scalars and vectors are what? The scalars and vectors are mathematical observation of physical quantities. Yes. The mass we have the so many operations. Yes. Fundamentally, mass contains 4 operations. You know very well. What is that 4 operation? First one is adding, subtractions, divisions, okay, no, multiplication. These are called the mathematical operations. Okay, it will be useful in everywhere in our physics also. Okay, clear or not? Yes, these are fundamental mathematical operations, whatever there, they are directly we are using. Means what? Suppose there is a mass is a vector, you know very well. 20 grams of one mass is there, 60 grams of another mass is there. Okay, clear or not all? Yes, we want to add these two masses. Simply we add the generally 80 grams enough. But in the vectors, it is not a possible like that. In the vectors, we are take account the direction also. Okay, clear or not all the students? Yes, we have to should take a direction also. And here there is a somewhat 2 products are there in a vector. One is the dot product, another one is the cross product. Dot product and the cross product. There is somewhat directions we are taken account. Okay, na? And as well as generally we are suppose a vector represent like that. Suppose velocity is there, na? Velocity is written as like this: 3i plus 4j. It is called a vector. The I indicates the direction of vector along one axis. Yes, the j indicates the another direction may represent it is y-axis based. Okay, na? Yes, we not add simply. Okay, na? Suppose we take v1 is like that, v2 is another vector, somewhat 4i plus 3j. Okay, we not add directly here like this. We have to add only the components of 3 plus 4 only. Okay, clear or not? We have to add the component of 4 and 3 only along the same axis vectors only, along the same direction things only. Not directly we added like this. Somewhat a process are there for additions purpose, for a subtraction purpose, for a okay, na? Yes, a product purpose. There is a division purpose also. Somewhat special process are there here. Okay, clear or not all this? Somewhat a special processes are there here. Direct adding, direct subtraction, direct multiplication is not entertained here. Got it or not? This is only about our yes vector multiplication and as well as the yes our whatever subtraction it is there. Got it or not? You get it is in your higher classes. In a 7th class also you have the same topic. In a 8th class also you have the same topic in our IIT foundation about the dot product, cross product and multiplications and additions. You are going to discuss on that particular place. Okay, yes, normal additions, normal subtraction is not a possible. Okay, clear or not? Suppose yes, F is equal to sorry, there is a one mass is there. Okay, the mass will be taken 10 times. Okay, na, clear or not? Yes, somewhat 60 is one of the particle mass. We want to take for a preparation of one solution 10 times. How much required means what? We directly will make it is a 60 into 10 600 grams. Okay, clear or not? But there is a what we want to take velocities accelerations a1 and a2 are the two vectors. We not make a direct product like this. Okay, clear or not? One body is moving with a 30 meters per second square acceleration. Another body is also moving with a 40 meters per second square acceleration. What is the product of these two things means what we are not take directly 30 into 40 1200. Okay, 30 into 40 we not take it is should be compulsory. We have to take directions also. Okay, clear or not all those students? Yes, and one problem is like that. Suppose Okay, now one car it is there. Okay, one car it is moving now in this particular direction. Okay, clear or not? This car is moving in this particular direction with a velocity of 2 meters per second. Next, it is the point at A. After it is point B, its velocity is somewhat decreases. Okay, now here when it will be reaches to this particular position, its velocity somewhat decreases 1 meter per second. Okay, now clear or not, all the students? Yes. Now we want to find out the product of these two velocities somewhere. Okay, clear or not, all the students? At that time, directly you don't go with the 2 into 1. Okay, now why? Because we have to take a direction also. Okay, clear or not? Suppose acceleration only we are taken here, we make a brake here. We are applied a brake on the car. Okay, the acceleration is now should become negative. When the acceleration decrease, it is taken as a negative retardation. It is called actually. At that time, there is we are taken it is not directly multiplication, directly okay additions of vectors. Got it or not? Yes, direct addition, direct multiplications they are not entertained in a vectors. Got it or not? We have required some special process for that purpose. Okay, now yes, this is only the difference between a yes mathematical application for the scalar is generally whatever we are used in a maths. That's it. But whatever mathematical applications we want to apply for the scalars, sorry, vectors, it is not a regular manner. We have to should take it is a some special manner. Okay, clear or not? That is only main difference is there. Got it? And next, after this, the fourth one, the examples are there here. There is a length, this and mass and time. Okay, clear or not? These all are called what? Examples for the scalars. Okay, now velocity, acceleration, force, momentum. Yes, these all are called as vectors. Got it? These are the four differences are very very important. Okay, first thing is only magnitude is enough. Here magnitude and as well as the directions. Both are required for it. And next one is the what? We represented simple by letters, but we represented compulsory arrow mark over the letters. And the mathematical operations are generally whatever there it is normal mathematical operations are only enough here, but normal mathematical operations are not enough for it. Okay, we required some special mathematical operations here. Got it or not? Yes, I hope you got it. These are only the differences between the vectors and as well as the scales. Now, let we go with our practice sheets. Okay, now, yes, whatever conceptual practice sheets is there and all these things. Now, whatever the practice sheet it is, once we consider it is conceptual sheets are page number. All the students are page number 35 it is. Okay, now yes, and the conceptual practice sheet it is. Question number 1. Physical quantity having only magnitude are called. What it is? Please give the answer to me from any branch. All the students, please involve in the class. Can I expect from any answer from the one in class? All the students. One in class. Any coordinator there? Please raise your hand or give answer in a message format. Yeah. Once again, I'm repeating. Is question number 1. Physical quantity having only magnitude are called. Yeah. Already we are discussing now only that is the scalar. What is that? That is the scalar. Next, second one. Physical quantity having both magnitude and directions are called. Yes? Are called what? Vectors. It is a called what? Vector. Next, a physical quantity that follows simple algebraic rule called as what it is? Scalar. Okay, na? Yes. Simple things only followed by it. Okay, clear or not? Next, an example of a vector quantity. An example of a vector quantity. Yes, velocity, energy, so many are there. Okay, na? Example for the vector quantity is a yes, what it is? Velocity. Yes, force, acceleration, like that. So many things are there. Got it or not? And next, after this, sorry, fourth question. The fourth question is, out of two quantities of pressure and force, the vector, which one it is? Yes, out of two quantities, pressure and force, the vector is what actually? Force is a vector or not? Force is a vector or not? It is a vector only. And suppose when you take a pressure, it is vector, it is a pressure or a scalar it is. Okay, actually both are a scalar only. Both are a vectors only. Okay, now both are vectors only. Pressure is also vector, and as well as the force is also vector only. Next, out of two quantities, weight and mass, the quantity that is not a vector, mass it is. Weight is a vector, mass is a not a vector. Weight is nothing but what? The gravitational force acting on the body. Okay, now the weight formula is the W is equal to mg. Okay, clear or not, all the students? Suppose one body is contain 10 grams of mass and acceleration due to gravity is 9.8 meters per second. Then there is about 98 newtons. Is called what? A weight. Understand all of you? This is a called, because of weight it is a fall down. One second, this top piece is a fall down because of it's a weight. Weight nothing but it is a one type of a force. Okay, clear or not? Yes, this is the changes from place to the place. Okay, weight is not a fixed, but mass is a fixed. Okay, now direction to direction. Okay, now weight is a changes here. Got it? This is only about a fifth point. Yes, this is a what actually it is a both are vectors only. Pressure and the force, both are vectors only. And next one, it is a what we are considered. Yes, a two quantities, a mass is. Please note down. Sorry, students, there is a pressure in the okay, same in all directions, but it is the only force. Answer is the force. Fourth answer force only. Sorry, pressure is not a okay now. Yes, vector. It is a scalar only. Force is a vector. Okay, it is the same in all directions. That is why it is the at a point it is the same in all directions. That's the direction will cancel. Yeah, this is about a conceptual work practice sheet. Okay, now once again I repeat the answer. The first answer is the scalar, second answer is the vector, third answer is the scalar again, fourth answer is the force, fifth answer is the mass. Okay, now next. After this, a scalar quantity is what the options are given. Always has a mass, is a quantity that completely specifies a magnitude, shows the direction, does not have units. There is a nothing will be considered here. The scalar is nothing but simply which is explained by the totally. It is by its a magnitude. Okay, clear or not? There is a mass is only called a scalar. Why? Because time is also scalar only. Okay, clear or not? Yes, it's not show the any direction. It's not show the any direction. Got it or not? It always gives only the magnitude. And as well as next, it's may have units, may not have units. If unit, it is called as a scalar only. Okay, clear or not? Some physical quantities may not have units, but it is a called a what? That physical quantity should it is only okay na? Compulsory it is a scalar either may vector. Okay na? But it will be when it will be discuss about the scalars and vector, there is a no use of units. Units are the both for it contain either scalar or vector, whatever the physical quantity you have to take, it is a contain yes units. Okay, clear or not? It is a contain what? It is a contain the units. Okay. Yes, that's why answer is what level 1 questions. Okay, now in the level 1, the first bit answer is what B. Okay, clear or not? First bit answer is B here. Okay, and next second one. Yeah, next one. Second point, a vector quantity. Yes, the next what is that? A vector quantity can be dimensionless and quantity and specify only magnitude, specify only direction, specify both the magnitude and direction. Yes, a vector quantity can be dimensionless quantity or specify only magnitude, specify only direction, specify both the magnitude and direction. Already you know very well what is the vector. It is a which contain both the directions and as well as the magnitude. Both it will be contained. That is why the answer is what again? It is the D. Yes, answer is D. Next, example for a scalar quantity. Here they given what? A velocity given, force they given, volume they given, acceleration they given. Okay, now the third point is answer is here C. Okay, clear or not all the students? Why tell me why the answer is C here? Yeah, when you require a velocity, when you want to explain about the velocity, compulsory we require what? Direction. Without a direction, we can't give a velocity. Okay, in which direction the body is under the motion and which direction it will be traveling somewhat distance. Okay, we start here. Okay, we are moving with a somewhat of 3 meters per second velocity. In case we not given a specified direction, it may not reach us to here. We want to reach us with this velocity from here to here. Because of that, it may not reach us to here. May we are not a given direction. May it is a 3 meters per second. May it is a 3 meters per second. After the second, it is may 3 meter. Yes, after the second, may 3 meter it here. Yes, like that. Anywhere possibilities. Anywhere may reach us here. When we provide a specific direction, at that time only it is reaches to this particular point. Understand all of you? Otherwise, may not reach us to this particular point. Got it or not? This is only about the what it is. This is only about our concept of velocity. Suppose the force. Yesterday I am already discussed with you. I am applying a force now in this direction. In this direction. That's why the chalk piece is moving. Okay, now in this particular way. Suppose I am changing the direction now. It will be moving in a cross direction. Okay, clear or not? Yes, I am applying my force. It will be moving in this direction. Otherwise, if I am applied in this direction, it will be moves in this direction. Is compulsory or not to specify the force? Yeah, that is why force is the what? Force is the vector only. Acceleration. Acceleration is nothing but change of rate of velocity. Velocity automatically it is a vector. Compulsory acceleration also become vector. But a volume is not required any direction. Suppose you take this chalk piece box. You know very well the what is the volume? What is the volume? Volume is nothing but what? Yes, volume is nothing but yes, length into breadth into height. Okay, clear or not? This go totally. This is my okay length. This is my height. Okay, clear or not, all the students? This is my length. It is. This is my okay na height. It is. This is my become what? There is. This is become what? This is the become breadth. Okay, clear or not? This is the length. This is the length. This is the height. This is the breadth. Okay, clear or not, all the students? This is become breadth for length, height, and as well as the breadth. Three-dimensional body. When you take a three-dimensional body. Okay, clear or not, all the students? Your compass box, everything. Your classroom. Okay, na length, breadth, and as well as the height. Okay, clear or not? These are called what? The product of the T things are okay, na? Yes, only called as it is only called as value. That is the changes that is required in a direction. No. Okay, clear or not? Yes, whatever may be the direction you are taken, it will become what? It will become same one. There is no need to change the position and direction, and we want to no need to explain about the direction. That's why the volume is become what? Volume is become what? Okay, now in the given things, there is the three things are there. Why it is a vector, why it is a scalar. That reason you have to know. Okay, clear or not? Why it is without a direction, it is not to specify, not to explain. Okay, clear or not? When there is a direction is there, okay, now at that time only it is explained, it is called a vector. Okay, now no need to the direction now. Okay, already yesterday I am discussed. Mass is why we are taken as a scalar. In a north side, I am this much of mass I am there. Okay, south side I am this much of mass is there. It is not need to required to represent here. Okay, got it? Yes, this is only about the concept of okay now. Yes, the vectors and as well as the scalars we are considered here. That's why the volume is a what? Volume is a what here volume? Scalar. Okay, that is the third answer. Next, fourth answer. What is the fourth answer? Okay, an example of vector quantity. Okay, now yeah, already they given. Okay, mass, volume, density, all are scalar. Force is a vector. Okay, now that's the answer is what? B. What is the answer? B. Next, the fifth question answer. This of the following is a vector. Okay, they given what? Somewhat units they given. Okay, you have to recognize there is a that whatever given things are belonging to which physical quantity. Okay, now what they given in a fifth question? In a fifth question, they given four options. A is 3 meter city, and next B 5 kg city, and C 8 joule city. Okay, now yes, D 3 meters due east. Yeah, tell me. Yes, there is a very important question. One second. This is a what actually we are considered. It is a meters. Meters is the units for which one? Either may velocity or may distance. Okay, now clear or not, all the students? Very very important. All the students listen carefully. This question is somewhat difficult. Okay, they given simply physical units not here. They given only the only they given the what? The units are given here. Physical quantities are not given. Okay, now we have to recognize physical quantity by using the units also. Then you have to know what is the units of physical quantities. In a first lesson, we already completed this measurement and units and dimension. In that one, there is already we completed somewhat the meters. Meters are measured for length. Okay, clear or not, all the students? Meters are measured for length. Okay, now and the meters for seconds are measured for the velocity. Okay, distance is measured for what? Distance is measured for okay, now distance is measured for this meters. Okay, now length, distance, these all are what? These all are scalars. Okay, clear or not? These all are what? Scalars. This is the distance. Distance is the what? Scalar. Okay, 3 meters. That's it. They said. They not said any direction. That is why it is called our distance. Okay, it is a scalar. Okay. Next, come to here. There is a 5 kg. Kg is a unit for what? Mass. Mass is a what? Scalar. Yes. 8 joules. Joules is the units for our work or energy. That's why it is also scalar only. Okay, na? They given what? Clearly they given, no doubt at all. Okay, already they given already hint for you. 3 meters due east. East is one of the direction. That is why this is the vector. Okay, remaining all are scalar. The 3 meters, same answer here. 3 meter, 3 meter. But they specify direction. It is become distance. It is become displacement. It is our distance. It is our displacement. When we specified one direction for a distance, it become what? It become what? It become a. It become what? It become what? It is a become as displacement. Okay, that is only they are considered here. Answer is D. Fifth answer is what? Fifth answer is D. Understood or not, all the students? The reasons are required for us. Answers are not a important here. What is the reason is that is important. This is a 3 meter. This is also 3 meter. But why this is not answer? Why this is the answer? Okay. And moreover, why the kgs are there? Why it is not a called answer for us? Why it is not called a vector? Why? Because the kgs are units for a mass. Okay, now joules are units for a work or energy. What you understood? There is these all are not a vectors. They are scalars. Which is a vector then? Which is specified by one direction. Okay, the 3 meters are specified by the direction east. Okay, now that is a direction. That's why it is a called. That's why it is a called vector. Understood or not? Yeah, please note down that all whatever answers are there here, and everyone must and should write a hint if possible. Okay, why it is only the answer? It is a specified direction. This is a scalar, this is a scalar, this is not specified the direction. Like that, you write a hint also. Next, we are going to level 2 questions. Complete past. Yeah, next I want to go with the level 2 questions. Yes, next level 2 questions. What is that? Jomi asked to complete physical assignments. Physics assignment are one of the things that he has to do. It's a represent a vector by a variable p in a direction in an equation. How will Jami represent a vector? How to represent a vector? Arrow mark on over on the letter. Okay, na? Yes, what they given? They given one symbol here. Okay, what is that one variable they given? What is the variable p? Okay, na? This variable when it is become vector, when we draw there is the one arrow mark over the letter, it is become vector. That's why the answer is become what? And answer is become it is a D. Okay, clear or not all the students? There is a given one more thing. They given like this. What is this? T answer they given like this. Any doubt may get? Yeah. When we write these two lines, it is become magnitude of this vector. We discussed later about this. The magnitude of these two vectors we want to represent. We write the two lines beside of it. That is called a magnitude. But simply when we write like this, it is called only vector only. Got it or not? No need to require to write any side lines. In case side lines are drawn, it is called what? It is called a magnitude. Okay, the answer is become D. Okay, the first answer is become D. Next, second answer. This of the following quantities are scalar in our nature. What the things are there? Distance, position, velocity, displacement. Okay, clear or not all the students? These following quantities is a scalar in a nature. Okay, now it's a nature is a scalar. Actually, the position is not a we are taken it is as a okay now. Yes, there is a scalar. We require a position where we are considering it, and a velocity is a vector only. Displacement is a vector, but distance is not a vector. Distance is a scalar. Okay now. Yes, that is my answer is become A. Okay, the second answer is A. Next. Eighth one. Which of the following quantities is a vector? Yes, they given what? Time, speed, distance, displacement. Displacement. The speed, distance, time. These all are what? Scalar. The remaining is only vector. Third one. Third question. Answer is D. Sorry, eighth question, no? 6 to 7. Eighth question answer is D. Okay. And next, after this, ninth question. This is the of the following is not true. Okay, the given ninth question. Velocity can be negative. Velocity is a vector. Speed is a scalar. Speed can be negative. Okay, this following is not a true. Velocity can be negative. Velocity is a vector. Speed is a scalar. Speed can be negative. Okay, now. Yes, which one is already we are discussed. There is a scalar may be positive or may be negative. Okay, velocity never become negative. Okay, clear or not all the students? Somewhat vectors are may become negative direction. That is a decreasing thing. It is called a negative, but it is not a negative. Okay, now that's why velocity yes can be negative. It is not a correct. But scalars, whatever the things are there, okay, now maybe positive or maybe negative here. Okay, clear or not? Here the speed is can be negative. Speed is a scalar, but a velocity is a vector, and it is a which vector? Positive vector only. Okay, there is no negative we are considered for it. Okay, that's why ninth one it is a become what? It is a become answer is A. Okay, clear. Next, 10th one. A quantity described by magnitude and direction, both it's a call. It's a called what? Vector. Okay, so many times it is repeated the question. The 10th question answer is B. All the students, please note down this. If you have any doubt, please tell me now. Tomorrow we'll go with the G advanced questions. Any doubt from any branch? Please note down these all the answers. Thank you.